Okay, students, so next is Rolle's theorem. Okay, so what Rolle's theorem says, see here the statement is given and I will explain with the help of graph. Okay, so the proof theoretically we don't need this one right now. So what Rolle's theorem says is, let f is a function defined from some interval is given. Can you see close interval to real set of real number, means there is a function which is defined whose domain is close interval a to b. A to b means this can be any number, any real number, say 1 to 2 or 2 to 3, like that. Okay, to set of real number means in this function, when you write down f of x, this x will belong from here and your range f of x will belong from set of real number, anything it can be. Okay, but this x should be from a to b. That's what we understand from the function, right? Okay, so if you have a function like that which is defined from some closed interval to real number, then see here, if f is continuous, means this function is continuous. Continuous means the graph of this function which will be given to you, whatever function is given. Okay, that function graph should not break, continuous on a to b. So I have already drawn the graph. You can see I have taken 2 points, suppose a and b, x value I have taken a and b. Okay, now you can see I have drawn a graph for that, whatever is the function. Suppose the function give graph this one. Okay, so see here, this graph should not break, first thing. Okay, condition is given if f is continuous on ab. Continuous means the graph does not break. Next, if f is differentiable on open interval a to b. Now see here, f is differentiable means what? This function which is given, whatever, suppose fx equal to x squared, something like this is given. First thing is, function must not, the graph of this function should not break, first thing, right? First condition. Second condition, if f is differentiable. Now what does that mean? Differentiable means what? We have studied from class 11 only, this one, right? Differentiable means slope of tangent, yes or no? So there is a curve, whatever is the slope of this tangent, that is called differentiation, right? Now see here, f is differentiable means what? F is differentiable means there must exist tangent, right? Because if there is no tangent, you won't have any differentiation at that point. Okay, differentiation means tangent must exist. Okay, now see what does that mean actually in the graph. In the graph, it means you cannot have a very sharp point like this, because if you have sharp point like this, can you draw tangent here? Obviously no. Tangent means what? From that particular point only one line can pass, only one line. So there is a line in a curve, you know that a line which touches exactly one point. Okay, exactly one point in the curve, that is called tangent. So you can see from this curve I can draw only one tangent touching one point. Why? Because you can see if I have to draw from another direction, if I draw like this from this direction, what will happen? It will touch 2 points. So from a curve, you know that tangent means it will just touch only one point, that is called tangent. Now see here, is it possible in this kind of point? Obviously no. Here you can draw many line like this, so this cannot be considered as tangent, means at this point we cannot draw tangent. Okay, I hope you have understood. From any sharp point you can draw many line touching only one point, see here. But if you have a curve like this, from this point how many line you can draw touching only this point? Only one, only this one. You might be thinking that I can draw from here also touching this point, but when you draw from here you will see that 2 point it will touch. From here if you draw 2 point it will touch. From here if you draw 2 point it will touch, like this. So from a curve, when you are able to draw only one line from a particular point touching that curve, then that is called tangent. Okay, so here f is differentiable means the function which you have, that function graph should not have sharp point. If it has smooth, you can see I have drawn a graph which is a smooth curve like this. Anywhere you can draw tangent except this point, because at this extreme point I cannot draw tangent. Why? Because tangent means what? There must be only one line which must touch this point, but from this point you can see I can draw many lines, so that cannot be called as tangent. Okay, tangent has a special property, right? So at this point also I cannot draw tangent. So at this point, that's why you can see they have given open interval, means A and B is not considered. Means when you have graph graph, it should not have any sharp point here. That means the graph is differentiable. Okay, because if you have sharp point here in between A and B, you can see if I draw sharp point, at that point you cannot draw tangent. Means you cannot draw tangent means what? It is not differentiable at that point. Okay, so what basically Rolle's theorem statement says is, first thing, there is a condition. Okay, a function which is given to you must be defined from some interval to set of real number, right? Now that function graph should not break, first thing. Second, that function should be differentiable. Differentiable means the graph which you will have, it must have smooth curve, it should not have sharp points. Okay, and the third condition, if fa is equal to fb, means y value, right, whatever function is defined at the extreme point, whatever it is, f of a, that is y value at that point, if it is equal, then see what happened. Three condition. First thing, Rolle's theorem must satisfy this three condition. What is that? F must be continuous, means graph should not break. Try to remember in this way through graph. This statement, if you simply try to memorize it, then you will not understand things properly. Okay, so try to understand with the help of graph. So Rolle's theorem, what it says is, if there is a function whose graph does not break and which is differentiable, differentiable means that graph does not have any sharp point, and if y value at that extreme point it is equal, you can see I have drawn at equal, this y value whatever it is, this y also will be same, I have drawn equal, then they have said that there will exist some c in open interval AB, means between A and B there will exist one point. Between A and B there will exist at least one point such that differentiation of that function at that point, at this point, what is the function? This one, right? Differentiation of that function will be 0. Now differentiation is equal to 0 means what? Slope of tangent is equal to 0. Right? Slope of tangent means tan theta is equal to 0. We have studied this one. That's why I said in class 11 only, whatever you are studying, all are based there. So if you haven't understand that one, then you will face difficulty here. Last time only I told you these are very important. We are making base for class 12. So this is how I was trying to explain you. Okay, so differentiation 0 means slope of tangent 0, and slope of tangent, slope when it can be 0, you know, slope whenever we find with the help of x-axis. Suppose this is the line, whatever angle it is making here, tangent tan theta, tan of that angle is called your tan of theta. This is called your slope of this line, right, slope of this line. So with the help of angle I can always find out what are the slope of this line, and with the help of 2 point also, you know, right, in a line how to find slope. If you know 2 points, then you can easily find slope, y2 minus y1 by x2 minus x1. This was the slope method to find out slope when you know 2 points, and when you know angle, how to find out slope, tan of that angle we used to find out. Simple, right? Now see here, tan of theta is equal to 0 means what? Theta must be how much? Obviously 0, means the angle made by the line, means this line, this function graph, the tangent, this will make how much angle with x-axis? 0. You can see, means this will be parallel to this one. So what basically Rolle's theorem says is, if you have a function whose graph does not break and it does not have any sharp point, and y2 if it is equal to y2 is if it is equal to y1, then there will exist one point between A and B. Any point it might be, because see, your for x value whatever you will take A to B, y value can be anything, right? Any real number. You can see function is defined from A to B to R. From A to B to R means a set of real number, means y value will be any real number. So graph can be like this, or it can be like this also. Like this also. The only thing is FA is equal to FB, means y1 is equal to y2. If it is equal, you will get 1 point. At least 1 point you will get, where the tangent of this point, tangent at this point will be parallel to x-axis. Parallel to x-axis means tangent means what? Differentiation. Differentiation at that point will be surely 0. Okay, if you have y2, and it's obvious, right? You can see if I draw randomly one graph. Okay, suppose I have taken y1 and I have drawn graph like this. Suppose anything I have drawn, and you have to get the endpoint to be equal here. If you have to get this and this and extreme point equal, then you will have graph always like this. Either it will have to come down like this, because it have to be equal, right? This and this. Either it have to come down like this, and if the graph is from from this direction, then it have to come back again here, because it must be equal, right? FA must be equal to FB. So whenever you draw graph, whatever kind of graph you will get, you have to come back here. So if you have to come back here, it's obvious, right? This is your x-axis, suppose here x-axis. Okay, these are the point. Then obviously you will get a point where whatever tangent you will have, it will be parallel to x-axis, means differentiation will be 0. It's obvious, right? So this graph, that's why I said the proof I will do with the help of graph only. Your theoretical proof will not do, and graph will only explain you the theorem. So I hope you have understood. Whatever is your y1, if your y2 also must be equal, then you know that whenever you will draw the graph like this, whatever it is. Now if y2 have to equal, the extreme point have to equal, then the graph will come back here, right? So when it comes back here, then it must be like this. See the curve from the downside also, if it is like this, then it have to come back up like this. So when it come back, then the curve whatever it will make, you know that it's obvious, practically you understand. Then if the curve have to be smooth one, means there will be no sharp one, then the curve smooth, if it is smooth one, then obviously if it come back here, then obviously you will have point like this, parallel to x-axis. Tangent if you draw here, it will be surely parallel to x-axis. Okay, so that's what Rolle's theorem says. So how to remember this one? Very simple. Rolle's theorem, how you will remember, there is a function, whatever function it is. Okay, it will be defined from one interval to set of real number, anything it is. You don't have to remember these things. Now what you have to remember, this function first thing must be continuous, means the graph of this function, whatever function is given, the graph should not break. First thing you have to check that one. Okay, should not break means what? Continuity you have to check, which we have already studied. Okay, left hand limit, right hand limit, find out, and that at that point find out the function what it will be. Okay, so if it is continuous at every point, means we will understand that the graph is not breaking. First thing you have to check that. Next, it should be differentiable. Differentiable we already have understood, right? What we will do for differentiability, how to check out left hand derivative and right hand derivative we used to find out, and we used to check whether they are same or not. If it is same, then it is differentiable, and through graph if you can find out, that is much more simple, right? So the graph should not have any sharp point. That's what practically I'm explaining you. Differentiation means that one only. Differentiation exists means the graph of that function does not have any sharp point. That's what it means. Okay, so this curve should be smooth one. Second case. Third, if f of a is equal to f of b, if these two are equal, then you will have 1 point. Okay, 1 point C, such that its function, whatever is the function here, if you differentiate that one, you will get that one 0. Means differentiate means what? You are finding slope of tangent. So if you find out slope of this tangent, you will get 0, obviously, because it's parallel to x-axis. Okay, you will get 1 point like that. So this is what Rolle's theorem is. So you better write down this one. I will give you the picture of this also, okay, in your classroom. So you just write down this theorem. And there was mean value theorem also, but the video will get lengthy to explain this one also. Exactly same mean value theorem also, only the case is here all are same. Only thing is here fa and fb, it's not equal. If it is not equal and if you have curve like this, then see here they have said there exists at least one point. At least one point you will have between a and b, such that its slope will be equal to, what is this one, you can see f dash c. F dash c means differentiation of c for this function, right? At c, whatever is your function, that is the differentiation, this one. So differentiation means slope. Now the slope of that function will be equal to this one. Now what is this? Now if you see well this one, fp, what it is? y2, y1. This is your a, suppose, then fa will be this one, right? y1, this will be y2. Now y1, y2, don't think differentiation, okay? Last time I told you, right? Different first order derivative, we used to write y1. I'm not talking in terms of that notation, okay? Only notation here. So this length is y1 I'm talking about, okay? So this is y1, this is y2. So here you see y2 minus y1, right? And what is this? B minus a. B minus a means this is your b. From here to here, whatever is the length, that this is your b. B means this is your x2. This is your x1. So can I say y2 minus y1, x2 minus, this is nothing but slope of this point is what? A comma y1, b comma y2. So y2 minus y1, I told you, right? For a line, if you want to find out slope, if you know 2 points, you can always find out slope of that line. So this 2 point I know, and I have seen that differentiation of this one means slope of this tangent is equal to this is nothing but slope of this line. Means slope of this is equal to this, means what? These are parallel. Now in this theorem what it says is, if f is continuous, means graph should not break. Second, again, should not have sharp point. Then there will exist, here fa is not equal. That is the only difference between mean value theorem and Rolle's theorem, okay? In Rolle's theorem fa is equal to fb, but in mean value theorem this condition is not given. If it is not equal also, then this condition will satisfy. Means there will exist one point c, at least one. You might have more than one, okay? At least one c such that the slope of tangent at that point will be equal to slope of the extreme line, extreme points, line, extreme line, okay? Extreme point line, you can say, line segment, okay? So the slope of this one, whatever it is, this also will be same, okay? Now see carefully, if b will become equal to a, means if you rotate this one like this and will make this one equal to this length. So if you bring this one this side, what will happen? This line also will become like this, right? Means what? This will become parallel to this one. So when you rotate this one, this also will rotate. Everything will rotate like this, right? So this slope will become how much then? Obviously it will become 0, because y2 and y1, if it is become equal, then y2 minus y1 will be how much? 0. So this will become 0 and it will become Rolle's theorem. So I hope you can understand. If I rotate this one like this, means this b if I bring here such that this and this length will become equal, then this value will become how much? 0 only, right? Means what? It will become Rolle's theorem. Why? Because you can see if you rotate like this, this also will rotate together. So this line will become parallel to x-axis, like before only, Rolle's theorem. So you can say Rolle's theorem is special case of this one, okay? If your fb and fa is equal, then this will become 0 and it will become Rolle's theorem. That was the third condition, right? fb is equal to fa. That is Rolle's theorem, right? So this you better write it down and try to analyze whatever I have said here, okay? Without analyzing yourself, you won't be able to understand this thing. So try to understand whatever I said in the graph, and if anything you didn't understand, let me know. I will explain this one again, okay?